Here we go. Okay. All right, so our learning goal for today's lesson is let's subtract sign numbers. We've been adding them, and today we're going to talk about subtracting them. So by the end of the class, you should be able to use a number line to subtract positive and negative numbers, and you can explain the relationship between addition and subtraction of rational numbers. Okay, who remembers what a rational number is?
Like fractions or ratios?
Yes, ratios, fractions. They can be written in terms of a fraction. Okay, good job. All right, we're going to do activity 2. Did anybody have questions on activity 1 or 3? No? All right, we're going to do activity 2, and that's the one with all the number lines, okay? So this one starts out, let me get all the questions down there. Okay, this one starts out with, here is an unfinished number line that represents a sum of 8. We know it's a sum of 8 because we've got a dot here on 8, and all we have is the first number that got added, and that was a 3. So the first question is, how long should the other arrow be? So how long should this arrow be? 8 units? I've already gone 3 units. So how many more?
Units.
5 units. Okay, so the question here, so this is going to be 5 units. All right, for an equation that goes with this diagram, mine writes 3 plus something equals 8. Okay, do you see where she got that from? 3 plus something equals 8.
Yes.
Okay, Tyler wrote 8 minus 3 equals something. So he took the answer, subtracted the number that we were given, and that's how he's going to find the something. Okay, do you agree with either of them?
I agree with both of them.
You agree with both of them, why?
Because the equation could be written either way, and you still get the same answer.
You're going to get this. You are going to get the same answer. 8 minus 3 equals 5, and 3 plus 5 equals 8. Okay? It goes back to, remember in elementary school when you did this? You knew that, and then you learned that you could take the answer and subtract one of the numbers to find the other number. Remember those fact families?
Oh yeah, I remember them.
Remember those fact families? That's all this is. That's all it's going back to. And now we just have an unknown number. Okay? All right, so you can say you agree with both of them because the equations are equivalent. So what is the unknown number? So what is this unknown number? Well, if we had to go 5 units long, the unknown number must be a 5. Is it a positive 5 or a negative 5? Positive 5 because we went to the right. Okay? So the number is 5, and we know that because the distance from 3 to 8 is 5 positive numbers. All right. Questions that you have for me about this first number line? All right. Anybody need more time to write it down? All righty.
This is not the practice problems, correct?
No, we are not to the practice problems. This is activity 2.
Yeah.
Okay. Remember from the first problem that Ma used addition and Tyler used subtraction. So now we have this number line. And it looks like our first number is what? Looks like it's -3. And our answer is 8 again. Okay, what equation would my write using the same reasoning she used before, making an addition equation? So what could Mai's equation be using addition? What do you think? Kimberly?
I think maybe -3 plus question mark equals 8.
Anybody want to agree with her? Give me a thumbs up if you agree with her. Nobody agrees? Oh, I got 2 people that agree. There we go. Simone, Rachel, do you agree? Chloe, do you agree? Okay, I need to see some participation. All right, Tyler writes a subtraction problem. So what would his be?
His would be 8 subtract 3 equals question mark.
8 subtract +3 or -3?
Positive.
+3.
What's this?
-3.
That number is -3, isn't it?
Yes.
So how long does the arrow have to be to get from here to here? 1, 2, 3, and then 8 more. So the arrow is how long? 11 units. Okay. What number would complete each of these equations? -3 plus 11, does that equal 8?
Yeah.
Okay. What about 8 minus -3? 8 minus -3, is that still going to be 11? Yeah, we just proved it, didn't we? Okay. So it's going to need a positive 11. Makes both of them true. All right. Questions on that?
No, ma'am.
Okay. Who needs more time? All right. Whoops, back, forward. Okay, now we are looking at, here's our first number, here's our answer. Our answer is now -8. So what equation would Mai write? Remember, she does an addition equation. So what's Mai gonna write?
3 plus question mark equals 8.
8 or -8, sweetie? Where do we end up at? -8. Okay. What would Tyler's equation be? Remember, he did a subtraction equation. Matthew, what do you think? Matthew Schaefer, what do you think? Tom, what do you think? Chloe, what do you think?
Can you do -8 minus 3 equals x or question mark?
Uh-huh. There it is right there. So how long does my arrow have to be? One, 2, 3 units, and then 8 more units, so it's gonna be 11 units long. But what is the number that completes the equation?
-11.
-11, because that one is going in the negative direction. It's going to the left. All right, questions you have about that?
No.
All right, who needs more time? All righty. So now we want to draw a number line diagram for -8 minus -3. And we want to find the unknown number, and how do we know? All right.
See, this is the part I was confused on.
Okay, ignore this dot right here. There shouldn't be a dot there. When you are drawing on the number line, you always go right unless you see a negative sign, and the negative sign will turn you around to go left. Okay, I'll say that again. Whenever you do a number line, you go right. You go in the positive direction unless you see a negative sign. If you see a negative sign, it turns you around and you go left. So looking at this first number, I see a negative sign, so it's going to turn me around and I am going to go left 8. So I am going to, if I turn this on, I'm going to start at 0 and I'm going to go to -8. Okay? Then I see this negative sign right here. Yes, you know it as a subtraction sign, but they all mean the same thing on a number line. Okay? This means I'm going to go left. Okay? So I'm going to turn around and go left. But what does this make me do?
Go backwards.
It makes me go right. It turns me back around to go right, and I'm going to go right 3. 1, 2, 3. So I'm going to go right 3. So my answer is -5. Because this double negative actually makes a positive. Questions you have for me?
No.
Wait, so that's a +5?
No. Where did I end up at?
-5.
-5. I went +3 because this turned me around to go negative, and then this turned me around to go positive. Because there are 2 negatives right here in this equation, I ended up going positive. All right, questions? Who needs more time?
No, ma'am. I do.
Okay, I'll wait a minute.
I'm good.
Good, okay.
Yeah.
All right, so remember we talked about this at the beginning where we had 2 plus something equals 5, and then we could do 5 minus 2, and that would equal to something, right? So let's look at a couple of examples just to refresh our memory. If we had 9 plus -1 equals 8, I can also say 8 minus 9 equals -1. Okay, if I have -8 plus 3 equals -5, I can say -5 minus -8 equals 3. So, what does it mean subtracting a number gets you the same answer as adding the opposite? What do you think that means? Subtracting a number gets you the same number as adding the opposite. Well, let's go back to -5 minus -8. Let's think about what that looks like on a number line. Here's 0. I'm going to go -5. 1, 2, 3, 4, 5. Then that turns me around to go left. This turns me around to go right. So I'm actually going right 8. And I end up here at 3. So how did this turn into an addition problem? What did I add to -5 to get 3?
8.
I added a +8. Okay, so subtracting is the same thing as adding the opposite. So I'm going to take that -5 and bring it down. I'm going to turn this into addition, and then I'm going to take the opposite of -8, which is +8.
Positive 8.
Is this right here what you see right up here? -5 plus 8. Is that what you see?
Yes.
Yes. And we end up with the same answer for both of them. So that is why we can say that subtracting, here's our subtraction problem, is the same thing as adding the opposite. I turned this into addition. So I turned this into addition, and then I took the opposite of this, which makes it positive. So now my equation is -5 plus 8 equals 3. Now why would we do that? Because you already know the rules for adding, and you don't have to learn a whole new set of rules. You can take those same rules that we learned on Monday and Tuesday and use them in subtraction problems, because we are going to change subtraction problems into addition problems by copy, change, opposite. Questions you have for me? Sounds a little confusing, doesn't it?
A little.
A little, okay. So let's look at a couple of them. How can we rewrite 5 minus 3 using addition? So what you do is you copy the first number, you change the subtraction to addition, and then you take the opposite of the second number. What's the opposite of 3? -3. Think about what this would look like on a number line. 5 minus 3 is going to equal 2. What is 5 plus -3?
2.
It is also 2. Okay? Now you probably wouldn't do that because you can do my 5 minus 3 easily. But let's take something like this. -6 minus 4. Well, I'm going to turn that into an addition problem by keeping the first number or copying the first number, changing the subtraction to addition, and then I'm going to take the opposite of 4, which is -4. You never change the first number, you change subtraction to addition, and then you take the opposite of the second number. Now we know the rules for this. Are the signs the same or different?
The same.
The same, so we're going to add them together. 6 and 4 make 10. They're both negative, so my answer is going to be -10. All right, when we get to something like this, it is even more confusing. But if we think about changing subtraction to addition, we already know the rules for addition. So this would be, we will keep the 7 or copy the 7, change the subtraction to addition, take the opposite of the other number. What's the opposite of -8?
Positive 8.
Positive 8. So now it becomes 7 plus 8, which we know is 15.
15.
So that nasty problem, that thing right there, is actually 7 plus 8. If we drew it on the number line, we would start out at 0, we would go 7. This is going to turn me around to go left. This is going to turn me around to go right. So I'm going to go right 8 more, and that's going to take me to 15. That's why the double negative turns you back around to positive. Questions you have? A little bit clearer? Okay, so this is what I want you to write down in the notebook somewhere. We can say that subtracting is the same as adding the opposite. I want you to start right here. Subtracting is the same as adding the opposite. Write that down. Subtracting is the same as adding the opposite. And we are going to change all subtraction to adding the opposite so that we don't lose negative signs. Who needs more time? Okay. So whenever you see subtraction, we will change it to addition by doing copy, change, opposite. So 14 minus negative 46 becomes 14, copy, change it to addition, take the opposite of negative 46. Negative 15 minus 75 becomes negative 15, copy that negative 15, change the subtraction to addition, take the opposite of 75 and it becomes negative 75. Then we'll follow the rules for adding integers or rational numbers. All right, you may want to copy down, copy, change, opposite.
I remember that in the slides today.
Good, great. Okay, any questions that you have for me? Anything I can clarify? All right, let's do some practice problems. Write each subtraction equation as an addition equation. So that goes back to that family thing that we talked about at the beginning. So we're going to start with the answer. So we're going to start with 6 plus 9 is going to equal A. Well, think about it. If I do A minus 9, is that going to give me 6?
Yes.
Yes. Okay. What do you think I'm going to do here?
Put in the opposite.
We're going to take negative 30.
Oops.
We're going to add 20. And that's going to equal P. Think about it. If I take P minus 20, does that give me negative 30?
Yes.
Yes. Okay. Same pattern. 15 plus
Negative 12.
negative 12 equals Z. If I take Z and subtract negative 12, do I get 15? Yes.
Yes.
Okay. Same pattern for this one. Start with negative 10. Add, what are we going to add? Negative 7, and that's going to give us X. So if I take X and subtract negative 7, does that give me negative 10? Yes, which is
Yes.
what that says. Okay? Questions you have on that? Who needs more time?
Me.
Okay,
A little bit.
I'll wait. Simone, you good?
Yes, ma'am.
All right, who else said they needed more time?
Me.
I'm good.
You're good? Jahan, are you good?
Hi.
Okay. Going once, going twice. Gone. All right, next one we're being asked to find the difference. All right, we can do 9 minus 4. What's 9 minus 4?
5.
5. That one's easy. That's left over from previous grades. All right, 4 minus 9. Think what it's going to look like on the number line. But we are going to change this to an addition problem. 4 plus negative 9. Copy, change, opposite. Are the signs the same or different?
Different.
Different, so we're going to subtract. Are there more negatives or more positives?
Negatives.
More negatives, so that would be -5. All right, 9 minus -4. Copy, change. What's the opposite of -4?
4.
+4, that's gonna give us 13. Think about what this would look like on the number line. I'm gonna go 9 to the right. It's gonna turn me around to the left, turn me around to the right, and I'm gonna go 4 more. Is that gonna look like 9 plus 4? Yes. All right, next one. I'm gonna copy the first number, change subtraction to addition, take the opposite of -4, and that would be +4. Are the signs the same or different? Different, so I'm going to think about subtract. Think about what that's going to look like on the number line. Here's -9. Now I'm going to do +4, so I'm going to have some canceling right here, and that's what subtraction means. Okay, do I end up on the positive side or am I still on the negative side?
Still on the negative side.
I'm still on the negative side because I have a longer negative arrow than I do a positive arrow. All right, -9 minus 4. Copy, change. What's the opposite of 4? -4. Are the signs the same or different?
Same.
The same.
Same.
Think about what that would look like on the number line. I'm here at 0. That negative sign tells me to go left, -9. This negative sign, also known as a subtraction sign, tells me to go left 4 more, so that's going to take me to -13. All right, what about this one? Copy, change. What's the opposite of -9?
Positive.
4 plus 9 is 13. We would go to 4 on the number line, we'd turn around and go left, we'd turn around and go right, and we'd go right 9, which would be 4 plus 9. All right, here's an even uglier one. -4 minus -9. Copy, change, opposite. What's the opposite of -9?
Positive.
+9. So we would go to the left 4, and then we would go left, right. We'll go to the right 9. Are the signs the same or different?
Different.
Different, so we're gonna cancel or subtract. Are there more negatives or are there more positives? Positive, so we end up on the +5. Okay, -4 minus 9. -4, copy, change. What's the opposite of 9?
Negative.
-9. Think about what this would look like on the number line. -4, that means I'm going to go to the left 4. This tells me to go to the left 9. So I'm going to end up at -13. What questions do you have? What do you need clarified? Who needs more time? Okay. Question 3. A restaurant bill is $59 and you pay $72. What percentage gratuity did you pay? Who remembers what a gratuity is?
I do.
It's basically like 10.
Isn't it a tip?
Yeah. It's the tip. It's what you leave for the server. So this is asking me what percent did I leave for the server? So that's a percent of change. Does anybody remember the percent of change formula?
Yeah. percent of change equals difference over, I think, original
Uh-huh.
times 100.
There you go. Awesome memory. And then we multiply it by 100 to turn it into a percent. All right, so we're going to take the difference of the two numbers. We're going to take the big one minus the small one, divided by the original. What's the original number?
15.
59. That's what the dinner originally cost. And then we'll multiply by 100. So if you have your calculator, 72 minus 59 is 13. You're going to divide that by 59, multiply it by 100, and you will get approximately 22%. Ran out of room going down. All right. Clarifying questions that you have for me. Anything I can clear up in your head? It's been a while.
Wait, so like the 13 out of the 59 to the 100, you have to divide?
Yep. This line right here means divide. 13
Okay.
divided by 59, and then
Okay.
you'll do times 100 to turn that into a percent.
Could you
Okay.
use cover, please?
Yep,
Never mind, thank you.
you're welcome. All right, who needs more time? Nobody needs more time? Okay. Find the solution to each equation mentally. 30 plus something equals 40. What's A gonna be?
10.
Good. Pretty easy. 500 plus B equals 200. Well, what am I?
Negative 300.
There you go. Good. We were thinking about that number line maybe. Thinking about negative numbers, because how can I make a big number go to a smaller number? I'm going to have to add a negative to it because I'm moving to the left on the number line. All right, -1 plus something equals -2.
-1.
-1. D plus 3,567 equals 0.
-3,567.
What's that called? What are these called? What is a positive 3,567 and a negative 3,567 called?
Opposites.
They are opposites. The math term is
Additive. Wait, no, never mind. It was when I was
Additive
thinking,
and inverse.
they are additive inverses. What questions do you have? Who needs more time? Alrighty. Onward to the last one. Oh, another table. We want to know, what is the interpretation of the constant of proportionality in this case? Where do we find the COP? When what equals 1? X or Y?
Y.
X.
X. When X equals 1, whatever Y is your COP. Think of the graph. Okay, whatever X is 1, Y, the value of Y is our COP. So it looks like we're going to have to do some figuring here. So I'm going to ask you a question. How do I get from here to here using multiplication or division?
Y over X.
I could do Y over X, but I'm going to think of it a little bit different. What do I have to do to 2.2 to get to 1? Divide it by 2.2. Do you agree? Okay.
Yes.
Okay. If I do that here, do I have to do it here?
Yes.
Okay.
For it to be proportional.
In order for it to be proportional. Good job. So what is 11 divided by 2.2? 5. Okay. What is 5.5 divided by 2.2?
2.5.
And what is 1 divided by 2.2?
0.45.
And it keeps repeating, correct?
Yes.
That's why I didn't want to use that as the COP, or doing y over x. Now, they want to know, what does the COP mean? It means 45 hundredths, about 45 hundredths of a kilogram per pound. Okay, so the COP means that there are about 45 hundredths of a kilogram per pound. Questions you have for me? All right, who needs more time? And this would be cell A, B, C. All right. Okay, last table. Now we're looking at it with kilograms on the left and pounds on the right. So when X is 1, Y is the COP, right? So can we answer this question right now? How many pounds are there in a kilogram?
2.2.
2.2. We can already answer that question. So now let's figure out the table. Is that our COP? So what are we going to do here? We're going to multiply by 2.2. Okay, and that would give you 15.4. Multiply by 2.2. That's going to give us 66. Multiply by 2.2. That one's going to give us 1.1. What question can I answer for you?
Is it possible if we can change those numbers on the chart into a fraction instead of having them into a decimal, or are they only able to be a decimal?
I would think in backpacks it probably wants the decimal
I have to go.
because they all terminate. Bye.
Bye, Miss Laird.
Bye. All right. So our next steps. You have independent practice. You have 2 Khan Academies to do. They're short. Make sure you enter these practice problems that we just did into backpacks. And you look at the lesson 6 slides for tomorrow. All right. If you need help on anything, I am on until 3:30. And I will see you tomorrow.
Bye, Miss Laird. See you tomorrow.
Bye.
Bye, Miss Laird.
Bye.
Bye, Miss Laird.
Bye.